Hello, my dear students. Once again, I welcome you all to another episode of Noble Mathematics. We'll find a way or make one. In the previous classes, we have seen what is remainder theorem and we have done few questions based on remainder theorem. In today's session, we are going to learn what is factor theorem and few questions based on factor theorem. On every Wednesday, I will post a video for class 10 students, and on every Saturdays, I post the video for class 9th students. If you like the video, don't forget to share it and to press on like button. So, without wasting more time, let us jump into the factor theorem. Today, we are going to see what is factor theorem. If p of x is any polynomial and a is any real number such that p of a is equal to 0, then x minus a is a factor of p of x. That is, if p of a is equal to 0, then x minus a is a factor of p of x, or x minus a is a factor of p of x if p of a is equal to 0. Here, p of x is a polynomial of any degree and a is any real number. Now, x minus a is a linear polynomial and it becomes the factor of the polynomial p of x if p of a is equal to 0. Similarly, we can use the factor theorem for other forms of linear polynomial such as x plus a, ax minus b and ax plus b. Here, x plus a is a factor of p of x if p of minus a is equal to 0. Ax minus b is a factor of p of x if p of b by a is equal to 0. And ax plus b is a factor of p of x if p of minus b by a is equal to 0. Here you can see the change of the sign. Here we have x plus a, then we take p of minus a. Here we have ax minus b, then we take p of b by a. And here we have ax plus b, then we take p of minus b by a. Let us understand this through an example. Look at the question. Check whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. Here we will represent this polynomial by p of x. Let p of x is equal to x cube plus 3x square plus 5x plus 6 and the divisor polynomial by g of x, so it is equal to x plus 2. We have to check whether x plus 2 is a factor of this polynomial. Here, since it is x plus 2, we will find the value of the polynomial for x is equal to minus 2. That is, p of minus 2 is equal to. Here it is x plus 2, so we take p of minus 2 is equal to, we will replace x with the minus 2. So minus 2 cube plus 3 into minus 2 square plus 5 into minus 2 plus 6. Minus 2 cube is minus 8 plus 3 into minus 2 square is plus 4 plus 5 into minus 2 is minus 10 plus 6, and it is equal to minus 8 plus 3 into 4 12 minus 10 plus 6. Minus 8 minus 10 is minus 18 plus 12 plus 6 is 18. Minus 18 plus 18 is equal to 0. that is P of minus 2 is equal to 0. You see here, if P of minus A is equal to 0, then x plus A is a factor. Therefore, we can say that by factor theorem, x plus 2 is a factor of P of x. Here, P of x is the given polynomial. So, this is how we can check whether the given linear polynomial is a factor of another polynomial. Now, we are going to do few questions from the NCERT textbook, exercise 2.4, question number 1, fourth one. There are 4 sub-questions under question number 1. So, here we consider fourth one. Check whether x plus 1 is a factor of x cube minus x square minus 2 plus root 2 into x plus root 2. Here, we represent this polynomial using P of x. Let P of x is equal to x cube minus x square minus 2 plus root 2 into x plus root 2, and the divisor is g of x, which is equal to x plus 1. So we have to check whether x plus 1 is a factor of the given polynomial. We will check it by using factor theorem. For using factor theorem, here we will take P of minus 1. I think you know why it is P of minus 1, because here we have x plus 1. So here P of minus 1 means the value of the given polynomial at x is equal to minus 1, which is obtained by replacing x with the minus 1. So it is equal to minus 1 cube minus minus 1 square minus 2 plus root 2 into minus 1 plus root 2. We are simply replacing x with the minus 1, and it is equal to minus 1 cube is minus 1 minus minus 1 square is plus 1. Here, this is minus, this is also minus, so minus minus will be plus. So 1 into 2, 2, again 1 into root 2, root 2. This minus and minus becomes plus. So 1 into 2, 2, plus 1 into root 2, root 2, plus root 2. On further simplifying, minus 1 minus 1 is minus 2, plus 2, plus root 2 plus root 2 is 2 root 2. Root 2 plus root 2 is just like x plus x, 2x. Here, root 2 plus root 2 is 2 root 2. And we can see minus 2 plus 2 will be 0. And finally, we have 2 root 2. Here, it is not equal to 0. Since P of minus 1 is not equal to 0, therefore, we can say that by factor theorem, x plus 1 is not a factor of given polynomial P of x. Here P of x is equal to x cube minus x square minus 2 plus root 2 into x plus root 2. So here x plus 1 is not a factor. Now look at exercise 2.4, question number 3, fourth one. There are 4 questions under question number 3. Here we consider the fourth one. The question is, find the value of k if x minus 1 is a factor of P of x is equal to kx square minus 3x plus k. So here it is given that x minus 1 is a factor of P of x. So in the solution, first we write P of x. P of x is equal to kx square minus 3x plus k. According to question, x minus 1 is a factor of p of x. If x minus 1 is a factor of p of x, by factor theorem, we can say that p of 1 is equal to 0. If x minus 1 is a factor of p of x, then p of 1 is equal to 0. P of 1 is equal to 0 means the value of the polynomial at x is equal to 1 is equal to 0, and it is obtained by replacing x is equal to 1 in the given polynomial. So we get k into 1 square minus 3 into 1 plus k is equal to 0. 1 square is 1, k into 1 is k, minus 3 into 1 is 3, plus k is equal to 0. K plus k, 2k is equal to minus 3 will go as plus 3. Therefore, k is equal to 3 by 2. So this is how we can find the value of the variable k if x minus 1 is a factor of the polynomial kx square minus 3x plus k. That is all for today. We will meet in the next class with some other questions of exercise 2.4. Till then, take care. Goodbye.